This is a 1991 Jeep Wrangler. Recently, my dad and brother have been converting it to electric. It runs off of these large Tesla batteries. Each of them have 5 kilowatt hours stored. Recently though, one of them, while testing, went bad. That battery is right here. Recently, we've been removing each individual cell with a piece of wood, like this. Wood is good to use because it's not metallic and it's a bit soft, so it won't damage the batteries. Wait, why are we doing this? Well, like I said, this battery recently failed. We think this happened because 2 of the cells in the battery got really hot. This is shown by discoloration on the metal, which we found in 2 spots. This means that only 2 cells in the battery are bad, so we decided to use the rest to make something. This is a 3 kilowatt portable AC power station. This is incredibly useful for things such as camping, to plug things in, or at home during a power outage, to run lights, or even the fridge and TV. However, look at that price. Most of that cost is the battery. If only we had a large, powerful battery that can't serve its old purpose any longer, but still mostly works. Oh wait! What we're going to do is we're going to make our own AC power station, and we're going to use that old Tesla battery to do it. Anyway, let's get back to the battery. First, you have to remove this plastic cover from the battery. That's not too difficult, so once you get past that, you can use pliers to remove this metal covering. This connects all the batteries. Once you get past that, your next challenge is this. This is liquid cooling strips that go in between the batteries. This is able to just lift out of the way. On other rows, you'll find this. This is just insulation that comes off very easily. Next, you're going to need to remove this plastic. This stuff is pretty tough, so you may need to get creative with how you take it off. It will free up some batteries to easily take out without needing the wood. Most of the time, though, you will need the wood. A wedge-shaped piece of wood is pretty good for getting out the batteries. Sometimes, though, you'll need to change up how you get the batteries out and work at them from a different angle, such as this. After removing the batteries, they need to be cleaned. They can be cleaned pretty easily by using a scrap piece of wood to scrape off any large plastic chunks. Small bits of plastic don't matter too much. This is important to do so the plastic doesn't get in the way later. Cleaning the batteries isn't hard, but it is time-consuming. After scraping off the plastic, we stored the batteries in a box. It's important when storing the batteries to not touch the positive terminal of one battery to any part of another battery. My dad can't have all the fun cleaning these batteries, so I'll do some too. Now, safety is important as well. You should wear safety glasses when breaking apart the plastic on the batteries, because small plastic pieces will fly everywhere and can easily go in your eye. Additionally, these Tesla batteries store a lot of power, and that means they can be a fire hazard. Be careful when working on them, and do not store them near flammable materials, such as fuel. After removing and cleaning the batteries, they need to be tested. This can be done with a multimeter just like this, set to DC max 20 volts. To test a battery, you need to take one of these 2 prongs and set it on the top here, and put the other anywhere else on the battery. If the battery works, the multimeter should show about 3.5 volts. However, when me and my dad were starting to test the batteries, we ran into some bad news. A battery that didn't work. So, we tested another, and it didn't work. So yet another we tested, and it didn't work. So we tested another. Once again, it didn't work. Finally, though, we found one that did work, and they started to get pretty mixed around with whether they didn't work or they did. As I tested the batteries, it got worse. Only about 1 in 4 worked, so we ended up having all these bad batteries, and only these good ones. It took a couple hours to do, but eventually I worked through all 444 batteries and was done. After going through all the batteries, we made a small test battery. We took 9 of the good batteries and used this conductive glue to connect wires to them. Then, we wired the batteries together. We made 3 sets of 3 batteries in parallel, meaning their positive and negative wires, respectively, were connected to each other. We then took those 3 sets and connected them in series, meaning the positive wires of one set were connected to the negative wires of the next set. After doing that, we ended up with this, our test battery. We then connected our test battery to an inverter we had, this thing. When we turned it on, though, it didn't work. We tried charging the battery with a car battery charger, but that didn't work either. This is when we figured that even the batteries that seemed good weren't. We tested this by connecting a resistor to the pack and measuring the voltage. We saw that the voltage immediately dropped when the battery had a load put on it. This means the batteries were all bad and the project was over. However, that doesn't mean it was all a waste of time. I learned a lot about electricity, like what series and parallel connections mean, and safety too. Even though the project was doomed from the start, I'm glad we at least tried. Thanks for joining us on this roller coaster of emotion, even though the roller coaster just went down and down until it crashed. Bye!